Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are going to discuss Dispersion Paper 1 classwork. First of all, please check the Telegram channel so you can find the KWL chart to write down what you know, what you want to know, and at the end of the session you write what you learned. Okay, let's start by question 1. Question 1 is asking you about which point on the screen does the infrared radiation reach. The infrared radiation, you know that if you have the electromagnetic family, the electromagnetic waves spectrum, and you know that you have the segment for visible light, which includes from red light ray to violet. Here you have the infrared and you have here ultraviolet. So infrared and ultraviolet, they are invisible. So here if you have the red color till the violet here, so you have the sun's radiation passing through a glass prism. The diagram is showing the spectrum of this radiation, and you have here the red one and you have here the violet. So the invisible one before red, this representing infrared, and after violet here you have the ultraviolet. Okay, so the answer of this question is A. Okay, let's go to question 2. When you have white light passing through a glass prism, dispersion takes place. Which row comparing here the refraction of violet light and the refraction of red light? Okay, at the first phase here, at phase 1, what happens at this point when white light travels from air to glass, which is a different medium? It refracts, it changes its direction, and the speed also will be changed, but the frequency will be the same. What happens here at the second phase of the glass prism? That also every single light ray in different colors also will be refracted when they travel from glass to air again. Okay, so they will be refracted. So what takes place at the first phase, phase 1, dispersion and refraction. But what takes place at the second phase, at this point, only refraction. Okay, so which row here representing the correct statement about refraction of violet light and red light? You will find that the violet refracts more at phase 1 and at phase 2. The violet will be refracted more, okay, because at the first phase it will bend towards the normal, and at phase 2 it will bend more away from the normal. So the answer is D, and we will discuss later in another question why the violet is refracting more. Okay, so violet refracts more at phase 1 and violet refracts more also at phase 2. Refracts means it bends more, okay, and it has shorter wavelength, and we will discuss it later on. Let's move to question 3. We have a narrow beam of white light into a glass prism here, and we have the spectrum of colors emerging from the prism. Here they are emerging from the prism. Which three colors do you see? Okay, dispersion means the white light is splitting. So what takes here inside the glass, the white light is splitting into different colors, and then it will emerge in air in order. They will emerge in order. The correct order, as you know that red, orange, yellow, green, blue, indigo, and violet. So this is the order. Which one of the choices we have here will show you the correct order? So we have red, so it's not blue then red, so this is not correct. Red, blue, yellow, no, this also is not correct. Red, yellow, and blue. Red, yellow, and blue one, so C is the correct choice. Is it clear? So take care, the correct order for the spectrum of colors emerging from the prism. Okay? Question number 4. Question number 4 is a challenging question. Why does dispersion occur when white light enters the glass? Enters the glass. Again, here we are talking what takes place inside the glass. What takes place inside the glass, as we said before, dispersion takes place and refraction. According to wave equation, as we said before earlier, that the frequency will be unchanged. The frequency will be constant. Okay? What happens when white light enters the glass? What happens is the wavelength of violet is shorter. The wavelength of violet, we know it's shorter. So accordingly, also the speed of violet will be decreased. Okay, so since violet, it has shorter wavelength, so its velocity, its speed will be less inside. So again, guys, when it enters the glass, we are talking inside the glass, okay? Not in air, inside the glass at this moment. So the speed of violet will be decreased more than red. The speed of violet will be decreased more than that of red. So you can get an information also from this question that the wavelength of red is more than the wavelength of violet. Since we are comparing, to be fair comparison, the frequency is constant. Is it clear? So this question is a challenging question and is very important. Okay, question number 5. Which diagram here showing what happens when a ray of white light passes through a prism? Again, here we are talking about dispersion. Okay, one of the common mistakes that you are confused between refraction towards or away from the normal. So what happens that if you draw a normal line here, if we draw a normal line to the first surface of the prism, okay, you will find that it will refract towards the normal, and then at the second face so this is normal and this is normal, so it will refract here in air again away from the normal. So the common mistake here that the students, you forget to recognize what's happening, what takes place inside the prism. So number one will be excluded. Why? Because dispersion takes place inside the prism also. So you have to choose between B, C, and D. But C here, it bends here in different direction. It's not away from the normal, and here also it bends in different direction. It's not towards the normal at the first face. Okay, so the correct answer is D, which means the white light at this point will be splitted into 7 colors. Each color, each ray will refract towards the normal at first face and away from the normal at the second face. Is it clear? Okay, the last question, question 6 here. We are discussing monochromatic light. Monochromatic, guys, it's not for core, but since this classwork for core and extended, and for you guys it will be general knowledge. Mono means one or single, and chromatic means color. Chromatic means color. So monochromatic light means you have color of single frequency and single wave length. Single frequency and single wave length. So the answer is A. And we consider laser as a monochromatic light. Okay guys, that's all for today, and do your homework and we will check it next time. See you in the next video.
Subscribe for more videos. I love Physics Blender. I love Physics Blender. I love Physics Blender. I love Physics Blender. I love Physics Blender.